So in solving equations, we have three different types. We have conditional, identity, and a contradiction. So your conditional equations, these have some true value solutions and some false solutions. This is normally what we're used to when we solve equations. We get answers like x equals 4 or x equals 5. You have identity equation. This means it's true for all values. There's infinitely many solutions. This means that no matter what you plug into that value, into that equation, it's going to come out true. Contradiction equation is the opposite. That means it's false for all values. That means there's no solution. So no matter what you plug in as that x value, it won't work. So if this is a conditional equation, then we're going to get one answer because our x only has an exponent. Just one answer. So we have one answer and then a lot of false values. If this is an identity, then it's going to be true for anything I plug in. I could plug in 0 and it's true. I could plug in 1 and it's true. They're both equal. Infinitely many solutions. And then we have the contradiction is that no matter what I plug in here, there will be no solution. Okay, so we're going to first determine if this is a conditional identity or a contradiction equation, or a conditional, an identity, or a contradiction equation. So all we do is solve it, just like before. So 12x minus 12 equals, and then we get 12x plus 32. And so if I now subtract the 12x, you'll notice that they cancel. This is what happens when you have these two. This is your x values cancel. So we end up with negative 12 equals 32. And now you can just read it. Is this true or false? And yeah, it's completely false. This is what happens when it's contradiction. If it's false for all values, it is a contradiction equation. Because it's contradictory. These are not equal. They never will be. And so the answer for this is no solution. This is what happens too. And so if you try to graph these two, they won't intersect. In fact, these two are both lines, and they would both come out to be parallel. They would never intersect. So no solution. All right, let's try another. So that's one of them. Now if this one, if we multiply everything by the common denominator, which is 10, this one we can just distribute. That would be 5x minus 20. That's 2x plus, and that would be 2 times 2 is 4. And then we solve. And we end up with 3x equals 24. Divide by 3, divide by 3, x equals 8. So that's the first one. This is a conditional equation. We got x equals some number, or numbers, but this is a conditional. And it makes sense because what's our condition? That x is 8. So this is true if x is 8. All right, so all we have left now is infinitely many solutions. So this should be an identity. So we multiply everything by x minus 3. And again, we're going to do that little trick where we split it. And then the x minus 3's cancel. So we get 2x equals 2 times x minus 3 plus 6. 2x minus 6 plus 6. And continuing to simplify, these two cancel. And there it is. See, I have 2x equals 2x. If I were to keep going, which is completely fine, you would get 0 equals 0. This is completely true. And if it's true, that means it's an identity equation. It means that they're both identical to each other. These are actually the same. So if I were to add these two together, you would see that they are exactly the same. Watch, let's just do that. So if I put this over 1, I do an x minus 3, top and bottom, I get 2x minus 6 over x minus 3 plus 6 over x minus 3. See the 6's cancel? This becomes 2x over x minus 3, exactly the same as the other. They are both equal, and that's why they're coming out identity. So we write infinitely many solutions. That's our answer. So these are the three you're going to get. So if it comes out false, you write no solution. If it gives you an answer, you circle that answer. That's your answer. And if it comes out equal to each other, true, a true statement like 2x equals 2x or 0 equals 0, infinitely many solutions. But there you go.